Hello everyone, welcome to Clashing Coder. So in this video we will see the question that is search a 2D matrix. So this video is a second part of the previous video, which was also same problem actually, but with different constraints. It was solved on Geeks or Geeks, so I will recommend you to solve that question first. That is also similar, search a 2D matrix, but it was only row and column wise sorted. In this we have the additional constraint, so this can be optimized further than the previous solution. So I will expect you to solve that problem first and then come to this video. So I will also provide the video link in the description and as well as in the I button. So I hope you will see that video first, then solve this question. So let's see the problem statement. So what write an efficient algorithm that searches for a value in m into n matrix. The matrix has the properties, following properties: integer in each row are sorted from left to right. So that means all the rows are sorted. You can see 1 3 5 7 and this 10 11 16 and 20. So these are increasingly sorted. So here you can see the first integer of each row is greater than the last integer of the previous row. So first integer of each row, you can see this first integer, for example this 10, is greater than the last integer of the previous row, which was this. So 7 is less than 10, so this is 2. So for every row you can see the first element of the row is greater than the last element of the previous row, that is 20. And what we have to do is we have to search a value, the target value that we are given in this matrix, and we have to return true or false if it exists or not. So we have to return true and false accordingly. And you can see this question has been asked in various interviews also for Amazon, Facebook. So this is a really important question from perspective of interview. So let's see. So you can see the constraints. So here are the constraints, and is the m dot matrix dot length, that means number of rows, and this is number of columns. And you can see they will vary from 0 to 100, and the elements will vary from minus 10 raised to power 4 to 10 raised to power 4. So let's see how we can solve this question. So actually the naive approach for this question will be similar to the approach I explained in the previous video. So I hope you will see that video, so you will be knowing this approach. So it will be simply searching the matrix, traversing all the matrix. Then the other approach will be, optimal approach will be to apply the binary search on every row, each row, and search the element. Then the optimal approach, the most optimal approach that we used in the previous question, can also be applied here. So it will be simply using a pointer and decrementing it and incrementing it according to the value that we are searching for. So if you have seen that video, so you will be knowing this method. So now let's see what is the difference between that problem and this problem. Because we are using the same solutions for both, but we can optimize this problem more than the previous problem. So let's see what is the difference. So in the previous problem, we were given that the row and column are sorted. This matrix is row wise and column wise sorted. So if we try to make it as an array, so as I told you in previous video also, you can see if we try to break it into array, that is you can see 10 20 30 40, and this you can see then 15 25 35 and 45. So here you can see, but now if you see, this is row wise and column wise sorted, but there is no constraint that the first element of the row is greater than the previous element or last element of the previous row. Here you can see this array is not formed in a sorted way. You can see 10 20 30 40, but here it is coming 15 25 35 and 45. So it is not sorted. But in this example that we are given on Leetcode, here you can see we are given that 10, this element will be always greater than the previous rows element. You can see this last element. So here you can see if we try to make the array out of this matrix, it will be formed as sorted array. You can see 1 3 5 7 10 11 16 20 23 30 and 34 and 60. Here you can see 1 3 5 7, and then you can see 10 11 16 20, and this 23 30 and 34 and 60. So this forms a sorted array. So actually if you see, if we are given the sorted array, okay, if we are given the sorted matrix, actually if we try to like think of it as an array, and we have to search a value, x value that we have to search, so we can simply apply an algorithm which is binary search. So if we apply binary search on a sorted array, it will just take log of n time, that is size of the array, log of size of array. So it will be really optimized approach. And in the previous approach that we used was n plus m. So that approach that we will use here will be actually more optimized than the previous approach. So this will be the difference between the two questions. So I will expect you to solve the previous question first, then come to this question, because both questions can be asked in the interviews as a follow-up. So let's see what will be the optimal solution actually for solving this problem. So as I told you, we will treat it as an array. So let's see. So if you see, so if you see, this is a matrix, and these are the indices 0 1 3 and 0 1 2. And let's see, so how the main problem that we will face in this is how we can map the array elements into the matrix. So actually if we compare this as a matrix, how we can run it a binary search on this matrix. So in array, binary search is simple. The left pointer will be on this, right high pointer will be, or right pointer will be on this, then we will find the mid will be 11 by 2, 0 plus 11 by 2, so it will be actually 5, so it will be coming here. Now we will compare the value that we are searching for, and we will go to left side and right side accordingly. But in matrix, how we can do that? So actually, if you see, the mid is this, okay? So here we have to find the mid. So our left pointer will be actually the starting value, that is 0. Here you can see I have initialized in the pseudocode, and the high value will be actually row into column minus 1. So how is that? You can see total number of elements will be this 3 into 4. 3 into 4 will be 12, but this is 0 based index, so it will be 12 minus 1, that is 11. So here you can see the 11, so h will be at 11th index. So this is the basic pointers, initialization of the pointers. Now we have to find the mid. So mid will be actually 11. So 11 will be 11 by 2 will be mid, that will be 5. So 5 is the mid, and the fifth element in this matrix is 11. So we have to map this element to this in matrix, how we can find the mid. So let's see. So these formulas that I have written are the important formulas. So here the mid is our mid is 5. So the C is our columns. Our columns are 4. So I will write here C is 4. Okay, so if you see 4, now our mid was 5. 5 divided by 4 will be 1. It will be 1. So that means our row will be 1. So you can see row is 1. Yeah, row is 1. Now if you see column, so column mid is 5. 5 modulus 4 will be again 1, because 1 is left. 4 divides 5 by 1, but 1 remainder will be left. So it will be again and 1. So if you see 1 and 1, so it will be this block, that is 11. And here you can see it was 11 here. So these formulas will help us to map the array into the matrix and apply the binary search on the matrix, that is a sorted matrix actually, in this problem. So this will be the approach that we'll be using. So these are the important formulas that you need to remember and use. That will be mid divided by columns will give you total number of columns, will give you the row of the element, and the mid modulus C, or the remainder of that, will give you the column of the particular element. So let's see how we can apply the binary search. So here as we know, I will initialize this left pointer to this value and high pointer to this value. It will be 11th, so it will be initialized here. Now while left is less than high, it will be typical binary search. So you can see left is less than high or less than equal to high, then we will find the middle or mid element. So mid element can actually be found like this also, L plus H minus L by 2. So this will avoid overflow. In the basic approach, we use L plus H by 2, so it can be overflowed. So we will use that here only. So let's see. So row will be actually found by, as you know, our mid, okay, left is here and right is here. So our mid will be 11. Now we will check this value. If this value, so we have to say, check for value 20. Okay, we have to check for value 20. And if you compare this value, so this is not equal to 11. So as we know, we have found the row and column. So row column of this value is here 1 and 1. Okay, row and column are 1 and 1. So now if you compare this value with this, is it equal to 20? No, it is not equal, but it is less than 20. So that means we will simply eliminate the left side, because left side will be smaller than the 20. So we will have to search for the right side. So we will increment our left pointer to mid plus 1. Mid is here. Okay, so it will be incremented to this. So now our left plus height. So this will be a remaining array that we have to search for. And the matrix also, this part will be simply eliminated. So our left will come here. Okay, we have to search in between this 16 to 20, and this 23, 30, 34 and 60. We have to search for the 20 value in between this. So our space, you can see space is really reduced. So now again our left and high, so next iteration will run, and our left plus high will be 6 plus 11 will be 17, and 17 by 2 will be actually 8. So 17 by 2 will be actually 8. So it will be at this point. Okay, mid is at here. So you can see, so 23. So how we can map this element in this matrix? 23, it will come to here. Let's see. So mid is 8 by C, that is 4. C is 4, as I told you, C is 4. Let me write it here. C is 4. Okay, C is 4. Now 8 by 4 will be, okay, it will be 2. So that means our row is 2. Yeah, row is 2. So 23 is in 2. Now we have to map to column. So mid modulus C. So 8 modulus 4 will be actually 0, because 4 divides 8 by 2. So it will be totally 0. So 0. So our next pointer will be here. So now you can see we have mapped successfully to our point where we were searching. So you can see we have mapped to this value, that is 23, and it is correct. Now we will compare 20 with 23. So 20 is less than 23. So that means this condition will be true actually. This high part will be true. So actually else part will be done, then high will be set to mid minus 1. So high is at this point, it will be set to mid minus 1. Mid is here. Okay, so high will be coming here. So now this part is reduced. You can see this part is totally reduced, and our left is here and right is here. Now again we will find left is here, right is here. You can see left is 6 and right is 7. So I am using this array to help you find use a binary search and see the indices. So you can see 6 plus 7 will be 13. So 13 by 2 will be 6 actually. So 6, now 6 divided by 4 will be, okay, it will be 1. So we will be at first row you can see, as it is a zero based indexing, so we will be, this will be our left pointer, this will be right, and our this mid element will be, this will be 1, mid that is 6, modulus 4 will be actually 2. It will 4 divide 6 by 1, but the 2 will be left as a remainder, so it will be 2. So you can see we are at value this, so our mid is at this point. Now if you compare this value, so it is not equal to 20, 16 is not equal to 20, but it is less than 20, so this condition will be true. Current is 16 and 16 is less than 20 that we are searching for. We will do L is equal to mid plus 1, mid is at this point, so L will come here, so both high and low will be at this point, that is 20. So both are pointing at this point. So let me clear this. So okay, sorry, let me clear this. So you can see our mid and high will be both pointing to the same element. So as you know, if both are pointing to the same element, that is 7, okay, in this point they both are pointing to same element, so left plus 7 by 2 will be 14 by 2 will be 7 only, so that means our mid will be at this point. So if you compare this value 20, so it will be equal to 20, but in matrix how we can map that? So we are in these points, we are calculating the indices for the matrix, actually the cell that we are searching for. So mid, that is 7 by C4 will be actually 1 only, and the column, that is 7 by 4 will be actually giving you 3. So you can see it is mapped to 1 and 3, so you can see 1 and 3, so this is 20, so our element is equal to, so we will return true. Otherwise if we have like exhausted all the indices and our left becomes greater than high, so this condition will break, then we will simply return false, because we have not been able to find the element that we were searching for. So this was actually very simple approach. Actually we were simply using the binary search, but instead of using it on simple array, we were mapping it to the matrix. So to do that, we were using this formula, that is to find the row and column of the particular cell. So we were using mid, and we were dividing mid by total number of columns, that was 4 here, so we were dividing the mid by the columns, so we were getting the row of the row index of that particular element, and by doing the modulus we were getting the column index. So we were simply checking for that element. If it was equal to, then we can return true. Otherwise if it was less than the target value, then we were doing L is equal to mid plus 1. Otherwise we were doing high is equal to mid minus 1. So the time complexity for this solution will be actually simply log of m into n. How is it that? Because you can see our total number of columns and rows were actually four columns were there and 3 rows were there. So if you multiply this 3 into 4, so it is becoming 12, and this was our time complexity. Actually you can see there are 12 elements in this. So actually the time complexity of binary search is log of n, and is the size of the array. So if you compare this matrix as the array, so if you compare this matrix as an array, so it will give you time complexity of log of m into n. So this will be more optimized than this approach which we used, where the constraint was not given, actually the particular constraint that we used here. So it will be n plus m, but here we got the time complexity of log m into n. So this is the most optimal approach for this solution actually. So here you can apply all the 4 solutions, okay, all the 4 solutions, but this approach will be the most optimal. So the space will be actually over 1 only, because we are not using any space. So let's see the code. So I will also share the code in the description, so you can refer the code from there. So you can see this is the code actually. So the base condition that you have to check is if the matrix is empty, you can simply return false. If matrix is empty, so there won't be any target that we are searching for. So then you can see the rows, total number of rows will be matrix dot size, and then the columns will be matrix 0 dot size, that is the first element's size, then first factor size actually. So then we will check if row and column is equal to 0, that means there is still no element, so you can skip this condition. This will be actually true here only if it is so here we have calculated the left, and actually initialize the left and the high pointer. You can see high will be initialized to the last element of the matrix, that is 60 here. So it will be row into column minus 1, and we will run the while loop here, which will be basically our binary search. So we will calculate the mid first. So mid can be calculated like this, so it will avoid the overflow using this formula. Then we will map the mid to the row and column. So it will map simply by, if row is actually, you can see we have to find mid. If we have to find this element 16, so it can be simply found by mid divided by total number of columns, and if we have to find the column of this element, so it can be simply mid divided by mid modulus c, so it will give the column. Then we will save the element into s for easy writing this easily. So it will be, then we will simply check if s is equal to target, we can return true, that means it exists. Otherwise if we will check if s is less than target, we will set our left pointer to mid plus 1, because we have to eliminate the search where it is not possible. Then we will if the mid is greater than the target that we are searching for, we will simply set the high pointer to mid minus 1, that means the element that we are searching is less than the elements that we are on, so we will simply skip those elements. Otherwise if this while loop ends, so that means we didn't find found the element that we are searching for, the target element, so we can return false. So let's submit this. So I will recommend you to solve the previous video question first, then solve this question. So if you have solved both this question, then if you are asked this question in an interview, will be probably be able to answer this question, and interview will be really happy to see that you know all the approaches to solve this question. So thank you for watching, guys. Do like this video and subscribe to the channel for more such videos. Thank you for watching.